How do lock-in amplifiers extract tiny electrical signals from noise? Imagine trying to hear a whisper in a noisy room. That's similar to what lock-in amplifiers do when they pick out tiny electrical signals hidden in a sea of noise. They use a clever method called phase-sensitive detection combined with very narrow filtering. The key is knowing the exact frequency and phase of the signal you want to find, which is called the reference signal. First, the lock-in amplifier takes the noisy input signal and multiplies it by a clean reference signal that matches the frequency of the signal you are after. Think of it like mixing two sounds together. This multiplication shifts the desired signal down to a low frequency or direct current level, while spreading out the noise across many frequencies. Because signals that are not at the exact same frequency are orthogonal, their noise averages out to nearly zero when you look at the result over time. Next, the output from this multiplication goes through a low-pass filter. This filter blocks high-frequency noise and unwanted signals, leaving only the low-frequency or direct current component. This component is proportional to the amplitude of the original signal at the reference frequency and phase. By narrowing the filter's bandwidth, you can reject more noise, but it takes longer to get a measurement. The lock-in amplifier can also measure the phase difference between the input and the reference signal. This helps it distinguish signals that are in phase from those that are out of phase, making the detection even more precise. The reference signal is usually generated inside the device or supplied externally, and it is typically a sine wave matching the signal's frequency. This process is very effective because it ignores signals at other frequencies and is not affected by slow changes or direct current offsets. It's a type of analog signal processing that uses multiplication and filtering to isolate weak signals buried in noise. This technique is widely used in experiments, sensor measurements, spectroscopy, and control systems where signals are too faint for traditional amplifiers to detect. In simple terms, lock-in amplifiers find tiny electrical signals by mixing the input with a known reference, then filtering out everything else. This way, they turn a faint, hidden signal into a clear, measurable one, making noise much less of a problem.